Okay, this is lesson 3.1, day 2. We're going to continue solving systems of equations. Yesterday we did solving systems by graphing. You're going to learn the other two ways. You have done this before. The first way is using the substitution method, and we're going to throw in a word problem at the same time. Alejandro has a computer business, or computer support business. He estimates that the cost to run his business can be represented by y equals 48x plus 500. That's his cost, is y equals 48x plus 500, where x represents the number of customers. He also estimates that his income can be represented by y equals 65x minus 4,500. Again, that's his income. So you have a cost to run a business, but you also have an income when you run that business. How many customers will Alejandro need in order to break even? Break even is back to where these two equations will intersect at, the point that they have in common. And what will his profit be if he had 60 customers? So first of all, we have two equations here. We have y equals 48x plus 500. And we have y equals 65x minus 145. So we're going to solve this system using what's called the substitution method. Up here at the top of the screen it says substitution. Substitution is where you take one equation and you substitute it into the other one, okay? So this y right here, I'll highlight it, is equal to 48x plus 500. But I know over here y is also equal to 65x minus 145. So what I'm going to do is I'm going to take this y and I'm going to substitute it into that equation where there's a y at. This is called the substitution method. Okay, so I took one equation and I substituted it into the other one. And now you just have a basic equation here that you need to solve. So go ahead and start solving that however you want to do it. I'm going to do it the way that I would do it. Okay, so when I solved it, I moved the 65 over and then I moved the 500 to the other side. I got negative 17x equals negative 645 and I divided by negative 16. So I got x equals 37.94. Up here at the top of the page it says x is the number of customers, okay? So the number of customers needs to be 37.94. Well, you can't have 0.94 of a person. So obviously you would need to round up to this one. So you need approximately 38 customers in order to break even. You would need 38 customers to break even, and then you'd be just a tad bit over that as well. Also, it says that what will his profit be if he had 60 customers? Okay, so this is a two-part question. So you can consider that part A. Part B is what will his profit be? So let me just tell you what profit is if you don't already know. Profit is the cost minus the income. Actually, I did that backwards. Huh. Doesn't make sense. Income minus your cost. So how much you bring in minus the cost of it, okay? So we had to figure out our income for 60 customers, then we had to figure out the cost of 60 customers, and then we're going to subtract the two. So our income equation from up above was 65x minus 145. But they told us that x was 60 customers. They said they want to know how much profit they'll have when they have 60. So I'm going to substitute 60 in here. And then just put that in my calculator. Just put the whole thing in your calculator in one step, okay? And so your income will be approximately $37.55. Okay, now we need to figure out the cost. And the cost equation was y equals 48x plus 500. Again, they told us that when you had 60 customers, that's your x. So I'm going to put 48 times 60 plus 500. And put all of that into your calculator all in one step. And when you do that, you get 3380. So your profit, again, is going to be your income, which is $37.55, minus your cost, which is $33.80, which that equals, grab my calculator, $375. So he brought in $37.55, but it cost $33.80 when he had 60 customers, so he actually only made $375. Now, the whole point in this problem, though, let me go back up, is using the substitution method. So they gave you two equations, and you had to substitute one equation into the other. We're going to do another one like that. Use the substitution method to solve this system. 5x minus 3y equals 23, and y equals negative 2x plus 7. Write those down. So again, I want you to use the substitution method. So what I do, you do not have to do this, is I put them beside each other. And you'll see why here in a second. So I just rewrite them beside each other. So I have one equation that I already know what y is equal to. So I'm going to take that and I'm going to substitute it into the other equation where there's a y at. Okay, so right where I drew that line at, instead of that y with that 3, I'm going to put negative 2x plus 7. So I'm going to rewrite this problem as 5x minus 3, but instead of y, okay, I'm not going to put y there because I know y is equal to negative 2x plus 7. And then don't forget to bring down your equals 23. So again, this was 5x minus 3y equals 23. And instead of y, I just put what y is equal to. Now you just are going to solve for x. So this is a basic multi-step solving equations problem. You're going to distribute a negative 3. So when you distribute a negative, you get 5x plus 6x minus 21. Okay, if you distribute a 3, your signs aren't going to be right. So make sure you distribute a negative 3 is equal to 23. Combine your like terms. Here I have a 5x plus a 6x. That's 11x minus 21 equals 23. Trying to get x by itself, so we're going to add 21 to the other side. You get 11x is equal to 44. So x will be equal to 4. Now remember, the solution to a system, is a point. Go back to what we did with the graphing. The solution to a system is a point. It's the point that they have in common. All I know is the x value at this point. I need the y value. So now what you're going to do is you're going to take this 4 and you're going to substitute it in right there. So I get y equals negative 2 times 4 plus 7. Negative 2 times 4 plus 7. So negative 8 plus 7, which then will give you a negative 1. Now again, your answer is a point. Points are x comma y. So your solution is the x value that we found, which is 4, comma your y value, which is negative 1. It is a point, so therefore you do need to have it in parentheses. And parentheses is how you denote a point in math. So your solution is negative, or 4 comma negative 1. And that's using the substitution method. Okay, we're going to do another problem like that. So for this next problem, I'm actually going to change what I originally had behind this box here for you to write down. We're going to do a different problem. So say I have negative 8x minus 6y is equal to negative 22. Negative 8x minus 6y equals negative 22. And the other equation is x plus 4y equals 19. Now, I want you to use substitution on this method, and it might not look like you can use substitution because you don't have the y by itself. And do not get y by itself. Do not do that. That'll give you fractions and it'll be a headache. What you can do is if you look at this equation, let me highlight it to let you know which one I'm talking about. If you look at that equation, okay, I can easily get x by itself by subtracting the 4y over. And when I do that, I'm going to get x equals negative 4y plus 19. So now I have x by itself. If I have x by itself, I can take what that's equal to, the negative 4y plus 19, substitute it into the other equation where there's an x at. So this time, I'm going to substitute in what x is equal to. And the other problem, we substituted in what y was equal to because y was by itself there, okay? But here, I can easily get x by itself by just by subtracting 4y over and then substitute it in. If you tried to get one of those equations y by itself, you're going to end up with fractions, and that makes it too difficult. I would not do that. So for this problem, I'm going to do negative 8. Instead of x, I'm going to write negative 4y plus 19. Minus 6y is equal to negative 22. Again, I just rewrote this problem, okay? But instead of x, I put what x was equal to right there, okay? Now, let's distribute and solve for y. You'll notice when you get to this step, the only variables that you should have should be the same variable. In this case, it's going to be a y. So let's distribute and combine like terms. So distribute the negative 8. That'd be a positive 32y. Negative 8 times 19 is a negative 152. Minus 6y equals negative 22. I'm going to combine like terms. I have 32 minus 6, which is a negative 26y, minus 152 equals negative 22. Try to solve for y here, so I'm going to add 152 over. I get negative 26y equals negative 22 plus 152, which is 130. I'm going to divide by negative 26, and I get y equals negative 5. And I'm hesitating here because I do see a mistake. 32 minus 6 is not a negative 26y, so I need to take out the negative there, and here, and here. So anywhere where I had a negative 26, I'm changing it to a positive 26. And then make that a positive 5 for my y value. Oops, forgot another negative right there. Right there. Okay. So again, 32 minus 6 was a positive 26, not a negative 26. So that gives me y equals positive 5. Now, if I know my y value, I can take what it is equal to, 5, and I'm going to substitute it into here so I can solve for x. So x equals negative 4 times 5, right, plus 19. Negative 4 times 5 is a negative 20, and negative 20 plus 19 is a negative 1. Now, if you stop right there, you're not right. You're not done. Okay, you need a point. A solution is an x comma y. The solution to a system is a point, and that's always x comma y. My x was negative 1. My y value was 5. So the solution to your system is negative 1 comma 5. That means if we were to graph those two equations, they would intersect at negative 1, 5. Okay, so that is solving systems using substitution. The next one is solving using elimination. I personally like this method better, but some people think it's more work. It just really depends. So you have negative 5x plus 3y equals negative 4, and you have negative 6 minus 4y equals 18. So for elimination, you want to be able to add straight down and get one of your variables to eliminate, to go away, to cancel. Right now, if I added straight down, negative 5 and negative 6 will give me a negative 11x, so that won't work. And if I added straight down a positive 3 minus 4, that would give me negative 1, and that will not work. So this is where you have to decide what you're going to multiply by in order to get the equations to eliminate. So say you want to eliminate your y values. Okay? If you want to eliminate your y values, these numbers, I'll highlight it, need to be the same. The 3 and the negative 4. They need to be the same number, but opposite signs. So one needs to be a positive, one needs to be negative, which you already have that, the positive and the negative. They just need to be the same number. So what if I multiplied this row by 4 and this row by 3? If I did that, then right here, I would get a positive 12, and right here, I'd get a negative 12. Positive 12 minus 12 cancels. It gives you nothing, so that's what you're going to do. Now, the mistake made here is that people forget to distribute to all three terms. So when you rewrite this, it's going to be a negative 20x plus 12y equals negative 16. And then you got to take this 3 and distribute to all three terms. You can't just do the term that you need. You have to multiply all three. So when I do that, it's going to give me a negative 18x minus 12y equals 54. Now when I add straight down, these cancel. That's what you want to happen. You want one of your variables to cancel. I chose y there. We could have chose the x and then multiplied by whatever we needed to multiply by. So now I'm going to add straight down, have a negative 20 minus 18, or negative 20 plus a negative 18. That'll give me a negative 38x. Add straight down over here as well. Negative 16 plus 54 is equal to 38. Divide both sides by negative 38. You get x equals negative 1. Okay. The solution to a system is a point, an x comma y. I don't have my y value. So what you're going to do to find the y value is pick either equation from above, one of the original ones, and substitute negative 1 in for x. So I always pick the first one. It doesn't matter which one you pick, like I said, but I always pick the first one. So I'm just going to rewrite the problem over here on the side. So negative 5x plus 3y is equal to negative 4. But now I know x is equal to negative 1, so that's equal to negative 1. So I'm going to substitute that in. Negative 5 times negative 1 plus 3y is equal to negative 4. Simplify and solve for y. So that'll give me a 5 plus 3y equals negative 4. We're going to subtract 5 over. I get 3y equals negative 9, divide by 3. I get y equals negative 3. The solution to your system, again, is a point. Negative 1, comma, negative 3. X, comma, y. So that's using elimination. You have to be able to look at the equation and figure out if you're going to eliminate your x's or your y's. It does not matter which one you pick, okay? And then once you choose with that, you have to figure out what you're going to multiply by, okay? Again, you have to figure that out. But the goal is what we did right here. I'll highlight it, what I'm talking about. Right here is to get, in this case, I needed a positive 12 and a negative 12. So I had to multiply by, I realized I can multiply them by 4 and 3, and then I'd have a positive 12 and negative 12, and that would cancel. So let's do another one like that. I have 3x minus 9y equals negative 48, and I I have x minus 3y equals negative 16. If I add straight down right in here, nothing eliminates. So again, if I add straight down, that's like a 3x plus 1x. That'd give me 4x. That won't help. Negative 9 minus 3 would give me a negative 12. That doesn't eliminate, okay? So we have to figure out what we can multiply by in order to get them to eliminate. Now, if I wanted to eliminate my x's, I would just need to multiply this row by a negative 3. And then that will give me a negative 3x there, which then will eliminate my x's. So I'm just going to rewrite my first line. I didn't touch my first line, so I'm just going to rewrite that as it is. And then I'm going to multiply everything by a negative 3. So I get a negative 3x plus 9y is equal to positive 48. Something special happens here. 3 minus 3 cancels. Negative 9 plus 9 cancels. That leaves me with 0 over here is equal to negative 48 plus 48 cancels. That leaves me with 0 equals 0. If that is a true statement, does 0 equal 0? Yes, 0 does equal 0. That means you have infinitely many solutions. So remember on the graph, that was two equations that were the same exact line when we were to graph them. Okay, so they looked like they were different equations, but when we actually graphed them, we found out they're the same exact line. When that happens, that's called infinitely many solutions. Now, say you get down to this step, you do all the work, okay? You add, multiply, all that, and you get down to the step, and say you get 5 is equal to 0. Is that a true statement? Does 5 equal 0? No, 5 equals 5. So if you get down here and it's a false statement, that would be a no solution. Okay, so if that were to happen, it would be a no solution. So those are the three types that you could still have using elimination. You can have an exact point, like this one. You can have infinitely many, or you can have no solution. And that completes 3-1, day 2.